Okay, so one given that we're told here in this problem is that PQ, this line right here, is tangent to both circles at the points S and T. So our job is to prove, knowing just that if we multiply PQ by TR, that will be the same as multiplying PR by SQ. So let's look at what they're even talking about here. Well, where's PQ? That's this line right here. And where times TR, this line, right? And then PR, this whole line here, right, times SQ, this line here. Okay, so here you might see that this is going to be a triangle problem because you've got similar triangles forming. We have that because SQ and TR are both radii of the circles meeting the tangents at points right here and here. That gives us right triangles, right? So here, you could start in your proof by saying line PT is tangent to circles, and you name circles by their centers, Q and R at S and T, and that's a given, right? Then you could say that radii, that's step one. Step two, radii SQ and TR are perpendicular, upside down T sign, to PT at S and T. And that's the definition of, definition of when radii meet tangent lines at the point of tangency, they're perpendicular. That's a definition. You can, and if you don't, I don't know if you have an official name depending on which class you're on for that definition. You could just say it over here. That is how they're defined. So in triangles, what is it? PSQ, right? So triangles PSQ and PTR, right? The small and larger triangle, they both have they both have right angles. So your next step would be just to say that. So we have, I put stars over here, but I think I'm out of room. I didn't set this up correctly. Let me just change the canvas size here. So we have these two triangles, and there we go. And we're trying to essentially prove that they are similar. Because once we can do that, we can just talk about the ratios in a fluent way. So, okay, so I've set that up, I fixed that. Let me just keep going. Our third step is to say that we have these two equal angles, right? So we have angle PSQ, I think it is, right? And we have angle PTR equal to each other, so we write that. PSQ is equal to, right, PTR. Fix this, sorry again, PTR. That's because right angles, right, equal themselves. Or I guess you could say all right angles are equal. So we got 3 steps in so far. The next thing I would say is both angles share this angle right here. So SPQ, right, you can call in the smaller triangle, and TPR are equal. So we have angle SPQ equals angle TPR. And this one you can say they're reflexive, right? This is essentially, sorry I spelled that wrong, reflexive property. These angles equal themselves. So now you have just 2 angles, right? And that's enough to show that both triangles are similar. So we can say triangles SPQ, right, we'll call them SPQ and TPR are similar to each other. Triangles, or the angle symbol, triangle SPQ is similar to triangle TPR, and that's the angle, right? Angle postulate. They both have two angles that are equal, and therefore they're similar, right? In a triangle, if two angles are equal, all three angles must also equal each other. Now that you have that, right, you basically have to find the corresponding sides. So SQ and TR are corresponding sides. And you might want to say that here. SQ corresponds to TR, and PQ, this side here we're looking at, corresponds to PR. So PQ corresponds to PR. Now this is, this is based on similar triangles, right? Have corresponding sides, however you want to phrase that. So and once that happens, right? Once you have these corresponding sides, and you can set up a proportion. And the one I would say is that you want to set up PQ over SQ, right? So that's one ratio. PQ over SQ is equal to PR over TR. PR over TR. Now, this is, right, just based on properties of similar triangles. Similar triangles, and I don't know how much you want to say here, but the ratio of corresponding sides in similar triangles are equal. And you can say that full statement again, that the ratios of corresponding sides in similar triangles are equal. And finally, to get what they want, this proof right here, we just manipulate the proportion. And you might notice that they multiply both sides by TR, right, and SQ. And once you multiply both sides by TR, you get PQ times TR, cancels it out on the right, and PR times SQ. And here you could say that the product, this is a fancy way of saying you cross multiplied, of the means, or the middle numbers here, that's SQ and PR, equals the product of the extremes. I don't know if you can read that. And that's really it for this proof. So you set this up by showing that they're similar by using angle, and then look at the ratio of the corresponding sides, and then manipulate the proportion. All right, hope this helped.